Hello mate, it's your Uncle Dave here. In the last one, we decided we wanted to make our own handheld Tesla coil. Found this one made by a guy called Dan DIY on YouTube who had included a schematic. Discovered that the best way to boost voltages is to use a transformer. Here goes. Which can sometimes boost them in a very frightening way. No, that's not good, is it? So I made my own transformer. Well, it sort of looks like a transformer. But now we're stuck because transformers only work on AC electricity and we've got DC in the battery. So what do we do? And what even is AC and DC anywho? According to Wikipedia, AC/DC are an Australian rock band formed in 1972. Wrong kind of AC/DC. To the oscilloscope. Let's do DC first, because that's what's in our battery. This up here is a DC power supply. So you can see I've got 2 volts here. So I've got 2 volts on these. When I switch it on, it goes up 2 of those divisions, so that's 2 volts. But it's only 0 or 2. So if I bring in some AC here, 2 volts, it's going up and down, isn't it? Up and down. And if I actually put these over each other, so DC in the middle, and I put the AC over it, and then I switch the DC on, you can see it's at 0 or 2. But the AC signal is going up and down past that 0 point and cycling continuously, and that's the difference between AC and DC. And a transformer only works in AC. But Uncle Dave, I hear you cry, we've only got DC in the battery, so what use is a transformer if it needs AC to raise our voltage level up? I'm glad you asked. This is where things get really quite clever. We need one of these. Yes, our old friend Dan suggests we use one of these, the SG3525. This guy has a datasheet. Do you know about datasheets? What kind of chip is it? It's a regulating pulse width modulator. What? All you really need to know is it's going to be used to switch our battery voltage one way and then the other, and then one way and then the other, one way and the other. Via these 2 MOSFETs, which are kind of switches that you can switch on with an electric charge here, going into these gates. First it'll switch this one, then it'll switch this one, then it'll switch this one, then it'll switch this one, and that gives us a sort of AC into the transformer. I've got this thing, this is called a breadboard. You can use it for making prototype circuits on. I'm going to put all of the components on here and then see if the circuit works and does what I want. Here we go then, a couple of capacitors, a chip, a couple of resistors, some wires, stick them all in the breadboard. 2 MOSFETs, very important, they're going to switch our DC up and down and sort of make a quasi-AC. Got the transformer hooked up. I'm going to connect the voltmeter to the output. Connect these things on. Whoop. Slippery little suckers. One on there. I'll give it the full beans. 6 amps. 4.7 volts. Not quite the 300 I was hoping for. I mean, that's obviously quite a lot less than we're putting in. This is not ideal. I think I figured out what the problem is. 0.5 volt. We do have the right signal though, look at that. This is the signal on the 2 MOSFET gates. You can see as one goes on, the other one's off, and as one's off, and the other one's on. So the problem is not there. Try number 5 or 6. I'm losing count. Got crazy readings. Let's see if anything's getting hot. Oh yes, 8.38 volts. Well, I mean, that's the most we've seen so far. So, yay! Very tired now. There have been so many separate problems I've found with this thing. So if I pull this one out, it should do it. 344 volts AC! It's working! It's working! It's been so hard. Oh my gosh! That can't be good. But you can't argue with 334 volts, even if it is smoking. And look at this beautiful waveforms up here as well. Yes, 331 volts AC. Woo! Hours hours on this. The breadboard, it had a broken connection inside the breadboard. The MOSFETs recently got off eBay are fake. Oh yeah, I put a capacitor in the wrong way around as well. But, oh, the relief. The relief. I worked so hard. There it is. Glowing. That's just that wire burning out. Everything else is working. So what we've learned from this is we need thicker wires and a lot of patience. It's such a relief. What do you think, Rips? Does it smell funny? Yeah. Good girl. This is how complicated it is to turn our 12 volts DC into 340 volts AC with our dodgy home wound transformer. And this is how simple it should be to turn that back into DC. In fact, it's just this bit here. This is called a full bridge rectifier, and it's just 4 diodes in this diamond shape. Let's have a quick look, see if I can find an animation of a full bridge rectifier. Here we go.
Diode is a 2-terminal device
From 3D Learning. So this is the AC going in here. And you can see as it goes up and down, he's showing it on this graph here, the diodes, because they allow the electricity to only flow in one direction, and it's reversing direction because it's AC, it sort of filters it and forces it all to go into this positive output. So you get this kind of slightly lumpy DC, but that'll be fine for what we're doing. But yeah, it's just 4 diodes in a diamond.
In positive half cycle the current flow through the blue arrow path, and in negative half cycle the current flow through the green arrow path.
But what is placing the capacitor for?
By placing the capacitor, we can smoothing the output voltage.
Thank you. Goodbye.
Filter.
AC goes in here and here. That's connected to ground, and that's the output. Maximum DC voltage here, and then the voltage divider leads back all the way into the chip. So this should give us some feedback. Oh no! I think I found a mistake in Bandan's schematic here. This is the feedback part here. Let me just get up Wikipedia on voltage dividers. It's just 2 simple resistors that go between the voltage and ground, and then you tap off the middle of the 2 resistors, and that gives you a voltage out. By adjusting these 2 resistances, get any kind of voltage out that you want. It's simple, and it's calculatable by this formula here. If we look at Bandan's feedback, it is just as simple as the one on Wikipedia. It just looks more complicated. The point is that this chip over here, it's looking for between 0 and 5 volts. So as this goes from 0 to 300 volts, this output goes from 0 to 5 volts. But if you do these calculations, and in fact even simpler than that, use an online voltage divider calculator, put 300 volts in, quickly look back at this, turning it down so we've got the lowest possible voltage coming out of here, which should give you the highest possible voltage here, which would mean that that arrow there was all the way down. So you had 100k ohm resistor there, and then you've got all of that resistance there in the potentiometer, which is 200k. So you've got 300 there, and that leaves 10k there. So let's put that into the calculator and see what it gives us. 310 kilo ohms at the bottom. Calculate 9 volts, way more than 5 volts. So it's actually going to shut down way before it gets to this 300 volts. So that means that this would not work. So bad, Bandan. He made a boo-boo. What I've decided to do is go and see if I can find another source on setting up the SG3525. I found instead this very nice chap. Look, there he is. Ahmed. Look at his lovely smile. And he did this really nice blog here. By the way, he's a PhD student at UC Berkeley. He's probably moved on from that now and become some top engineer somewhere. But he's done a nice sort of definitive blog on using the SG3525. So I have actually rebuilt my SG3525 circuit to use this schematic now, which I'm much happier with. And I've changed the feedback values because I want slightly different voltages. Designed this part myself. As long as my calculations are correct. Let's see how that goes. Designed to produce somewhere around 300, 310 volts, hopefully. Okay. Douche. It's gone up to 500, 560, 570. There's smoke. There's smoke. 570. Oh, fire. Buzzing sounds. Powering off. I wonder if it needed to have a load on the end. So now I've got two 1K resistors in series, and got the voltage divider down here connected between the two of them, and everything else is the same. So let's see. 265. That's getting up there, isn't it? Yep, you can see the wires beginning to glow. Diodes are hot. Big resistors are hot. I mean, there's power. There's power going through it. Mate, I struggled on and on and on with this circuit, and it was just working intermittently the entire time. So I pulled it apart, completely rebuilt it. I was thinking about it in my sleep last night. Went for a run this morning and I was thinking about it, and then towards the end of my run, ding! But there's a light bulb. Ding! Perfectly normal looking wire. Connect one across that end and to the centre tap on the transformer. 186 ohms. This is not a wire. This is a resistor. It did not melt the outer cover, so I've never seen that happen, where if you had a wire burn out, it looked normal still. So I think if I replace this wire, and I'm also going to take the opportunity to quickly knock together something a little bit more professional-ish looking. I'll put it on some board. It's better because it's soldered. It eliminates a lot of worry. For example, weird wires. Sometimes I think it's better than just a breadboard because it makes your circuit less fragile, and other times I think it's not really worth the bother. But anyway, I'm rebuilding the power supply, 300 volt generating bit, and I realise that I need two separate heat sinks for my MOSFETs, so I'm cutting them up on my thingy. There they are. MOSFETs in, a couple of resistors between the gate and the source, the big fat diodes going into the full bridge rectifier. There's the chip, various capacitors, all of the rest of it as before, but now soldered together to give a false sense of security. And a switch, so you can switch it on and off. But things did not go smoothly. I'm just about done with this thing. Oh, what's it doing? Because this circuit has been kicking my bottom for hours. That's not good. Did you see that? I'm not doing any more work on this ever again. Trace on the board burned out. Cool. But I have got a result, and now it does generate 300 volts. 301.6. Yeah! That's an old-fashioned light bulb like they don't have anymore. Very good test load. Waveforms, light bulb, lighting. That's it. That's it. The only cost of the whole thing was this. Absolutely trashed. Not my fault, of course, but entropy itself, the universe itself, it absolutely never, ever ends. But, success? Yeah. Thanks to entropy, any room without an external organising influence will tend to a state of disorder. My room is no exception. The only way to beat the universe is to tidy up. Yes, the best. Yes, the best. Yes, the best.